Welcome to the Deep Dive. Today, we're plunging into a really big topic. It's reshaping app development, but honestly, it's also raising some significant flags. AI safety.
Yeah, it's huge right now.
Specifically, we want to look at how we can build robust safeguards, people call them guardrails, for these powerful AI systems, the foundation model-based agents.
That's the focus.
And our mission, really, for this deep dive is to unpack this fascinating research paper. It uses a surprisingly straightforward analogy.
The Swiss cheese model.
Exactly, the Swiss cheese model to explain how these, crucial multi-layered guardrails actually work. It's all about understanding how we make sure these increasingly autonomous AI agents behave safely and responsibly for you, the listener.
So maybe we should start with the basics. These foundation models, or FMs, they're essentially massive machine learning models. They're pre-trained on just enormous amounts of data.
The bedrock for lots of systems, right?
Precisely. And the agents built on them, FM-based agents, they're designed to be autonomous. They perceive, they reason, plan, execute workflows.
All using these FMs.
Using the FMs, yes, but also external tools, knowledge bases, all to achieve goals that humans set. And this is the key thing, their autonomy and their non-deterministic nature.
Meaning they don't always react the same way?
Exactly. Even with the same input, you might get a different output. It makes them hard to predict. And that introduces pretty substantial AI safety concerns. We're talking about generating harmful content, maybe dangerous outcomes, or, spreading misinformation.
Okay, that unpredictability, non-deterministic behavior. That really stands out. It feels like that makes simple, single-layer safety rules almost impossible.
It really does.
Is that why this layered approach, like the Swiss cheese model you mentioned, becomes so vital, instead of hoping for one perfect wall?
Precisely. That's what the paper argues. It borrows this idea from risk management. You picture each protective layer in the AI as a slice of Swiss cheese.
Okay.
Each slice has weaknesses, right? Holes. But, and here's the clever part, the holes are in different places on each slice.
So they don't line up.
They don't line up. So the idea is a risk might slip through a hole in one layer.
But the next layer, with its holes elsewhere, is likely to catch it.
Exactly. And for AI, this is brilliant because failure isn't usually just one thing going wrong. It could be a bad prompt, a reasoning error, a tool misuse. Each slice isn't just a generic filter. It targets a specific potential weak point in that whole complex process. The combined layers give you a much more robust defense.
And what I find really interesting is that these guardrails, they're not just basic stop-go commands, are they? They're actually designed to ensure specific qualities.
That's right.
Which, for you listening, really translates to making the AI trustworthy, but in, different ways.
Yeah, multiple dimensions. Take privacy, for example. Remember that whole thing with Samsung, where employees accidentally fed a proprietary info into ChatGPT?
Oh, yeah, that led to a ban, didn't it?
It did. So guardrails are designed to prevent that kind of data leak, whether it's direct leakage or someone trying to cleverly infer sensitive info.
And security is massive, too. I definitely remember Microsoft's Tay chatbot disaster.
Oh, Tay.
Yeah. Malicious users basically turned it into, well, something awful. It got shut down fast. Guardrails have to protect against that kind of manipulation, things that compromise the AI's integrity.
Absolutely. And then there's accuracy, mitigating things like AI hallucinations, where the model just confidently makes stuff up.
Right. Sounds plausible, but it's totally wrong.
Exactly. Or just spreading misinformation or disinformation. Guardrails can even push AIs to label their own generated content. Think about fighting deepfakes. It's this constant effort for trustworthiness that's so vital, especially with how fast things are moving. Really makes you think about information itself, doesn't it?
It really does.
And connecting this back, these guardrails, they aren't just tacked on at the very end. No, they're woven throughout the agent's architecture. They're applied to all sorts of targets, like the user's initial prompt coming in.
Okay.
The intermediate results as the agent is working through a task, and obviously the final results it gives back to you.
Yeah.
But also deeper stuff.
Deeper.
Things like the agent's core goals, its working memory, even the specific tools it decides to use. Because any one of those could be a potential point of failure or risk.
Okay, so they're everywhere. How do they actually intervene then? What actions can they take?
Well, the paper mentions several. There's block, which is pretty straightforward, just stops a bad input or output completely.
Right, stop.
Then there's filter, more nuanced. It scans and removes maybe just the undesirable part, letting the rest through.
More surgical.
Kind of. And flag is really important, marking something suspicious for a human to review. Because automation can't catch everything.
Makes sense. Human in the loop sometimes.
Definitely. Or even direct human intervention in critical cases needing immediate oversight.
Gotcha.
And all of this needs support. That's where the AgentOps infrastructure comes in. It's absolutely vital.
AgentOps, like DevOps, but for AI agents.
Sort of, yeah. Think of it like the AI's black box flight recorder combined with a continuous learning center. It monitors and logs everything.
Everything.
Runtime data, pipeline execution details, which guardrails fired when. It's crucial evidence, sure, but more importantly, that data feeds back.
Feeds back how?
To improve the system. It helps activate the right guardrails when needed, and it allows developers to constantly refine and strengthen those cheese slices as new threats pop up. It makes the whole system more resilient over time.
Wow, okay. That feedback loop sounds critical, especially for systems that are constantly learning and evolving anyway. So it's genuinely about building AI safety by design, baked in from the start, not just patching holes later,
Exactly. It has to be foundational.
which feels incredibly important as we rely more and more on these autonomous agents, right?
Absolutely. And it brings up a fundamental question, really. As these agents get more autonomous, more woven into our daily lives, how do we make sure they stay aligned with human values and intentions, not just on paper, but in every single interaction, adapting as new challenges arise?
That's the million-dollar question, isn't it? So the next time you interact with an AI, maybe take a second to think about those unseen layers of protection, working away like those slices of Swiss cheese, trying to keep things safe and aligned for you. It does make you wonder, what other complex systems, maybe even human ones, could really benefit from that kind of robust, multi-layered thinking about safety?